Hello and welcome to lesson 3.6, writing equations. So far in this chapter we've been graphing equations. We've been saying, oh look, if I give you this information, could you figure out what the equation looks like? Now we would like to be able to kind of go backwards. A lot of things in math you learn how to do it one way, then how to undo it. Like your whole math career, you learn to add, and then the next year in second grade you learn to subtract, which is kind of undoing adding. You learn to multiply, then you learn to divide. If you go to calculus, you learn to do derivatives, and then you learn to do antiderivatives or integrals. It's just kind of the way things roll. You learn to uh, evaluate expressions, then you learn to solve for x and go the other way. So we learn to kind of go back and forth. So in this case, we would like to say, instead of giving you the equation and seeing if you could pick out information or seeing if you could graph it, we would like to give you information and see if you can go back to the equation. Now the way we're going to do this is one formula called the point slope formula. And this is one you'll want to commit to memory, just like the other two formulas we've had in this chapter, the slope one and the slope intercept. And this formula goes like this. It's just y minus y1 equals m parentheses x minus x1. And some of these pieces might look familiar. This is actually just a rearrangement doing some algebra to the slope formula. Okay, and the way this is going to work is we're going to need the x and y point values from a point. Those are pieces we'll plug in, and the slope. So from a point, from the point, from the slope. This one stays an x, this one stays a y, so it's just three numbers to plug in. So every time you go to do this, you have needs. The needs you have are just a point with an xy pair and a slope. Well, that makes sense then why they call it the point slope formula. So all we'll do is plug in our three numbers and then we'll try to simplify it to get it to be y equals, which is just always the same two steps. You'll distribute the m and move this number over, and you'll be done every time. Now the only level of difficulty kind of shift that we do with this is that we might or might not give you different information. The easiest thing, or what we begin with, is we begin with saying, okay, write the equation. If I were to give you a point and the slope. So let's say it's through the point negative 3. Negative 3, 4 is the point we're talking about. And let's say we have a slope of, we know it has a slope of negative 2. Find me the equation. Well, we will use the formula. I will suggest we write down the formula until you start to memorize it. Y minus y1 equals m parentheses x minus x1. And so we're going to just look, every time I do these, I like to write my needs out to the side. So I need a point and I need a slope. And guess what? This problem is the easiest variety we'll give you. Guess what we've given you? We've given you a point. Yay, we happen to have the point negative 3, 4. Check, I got that. That need is met. And they give me the slope. Negative 2. Yay, that was really easy as well. They gave me the slope. I have both needs met. Now I can do the problem. So let's plug in these things. You may want to, if you remember some of my style here, is label these as your x1, y1. And then that should help in the plugging in process. So y minus, what is y1? 4 equals m. What's my slope? Negative 2. X minus, what's my x1? Negative 3. Be careful with signs here. The formula has subtractions in it, so be careful plugging in negatives and positives. Keep this subtraction and put your sign with your number. So now, I do need to realize that if I have minus a negative, that's the same thing as adding a positive. And I should be able to get this finished off in the y form now. So I've plugged in the formula, they gave me the numbers, that was a piece of cake. Now I just need to do two steps to simplify. I need to distribute. They're always the same two steps. Distribute negative 2 times x is negative 2x, piece of cake. Negative 2 times a positive 3 is a negative 6. Now we're almost there. I just need to get y by itself, so I need to get rid of this minus 4, so I will add 4 to both sides. Being very careful with signs, y equals negative 2x. Let's see, 4 is a number, so it'll add to a plain number. Can't add to the x term. Negative 6 plus 4 is a negative 2. Nice, and so we finished the problem. Look at that. This is actually really easy, but it's what most people consider the hardest part on this test. But all you need is a point and a slope. We gave you a point and a slope. You plug in those three numbers from the point and the slope, and then you do two steps. You distribute, and you move this term over, and you're finished. And that is the entire lesson. I'm going to work different examples, and I'll also give you different information. Okay, but that's all we're doing the entire lesson is. You get a point, you get a slope, you plug in your three numbers, you distribute, you move the thing over. So let's do another example. Okay, write the equation. And let's say I give you, instead of a point and a slope, I'm a little bit more evil, and I give you 2 points. The 0.13 and the 0.27. And you panic and you say, oh no, I have these needs, and I don't think I have both of them this time. I need a point, and I need a slope to be able to do this. And we feel a little bit panicky. Well, let's just go through these. Do I have a point? Yes. I have 2 points. Which one do I use? Oh no, now I have a choice. Guess what? No matter which point you use, if you do this correctly, you will get the same answer. So pick the one that has simpler numbers. So I'm going to use the 0.13. If you want to use 2.7 throughout this example, fine, but we'll get the same answer. Now we need the slope, but I don't have the slope, so we feel panicky. But wait a second. Don't we know how to find slope from 2 points? The answer is yeah. We can use the slope formula to find this slope. And so you may want to label them x1, y1, x2, y2, and remember your slope formula. This is good practice. So 7 minus 3 over 2 minus 1. y2 minus y1, x2 minus x1. So 7 minus 3 is 4. 2 minus 1 is 1. 4 divided by 1 is 4. So we have point and a slope. So now I should be ready to rock and roll. This is not hard at all. So many people are scared of this for no good reason. And so I can plug in my 3 numbers. What's the y value from the point I'm using? 3 minus 3. What's my slope? We found that to be 4. X minus, what's my x value? 1. All right, feeling good. This shouldn't be too difficult. I need to do my same 2 steps of algebra. Distribute. So 4 times x is 4x. 4 times a minus 1 is a minus 4. Piece of cake. And then I need to get the y by itself. Add the 3 over. So y equals 4x. And minus 4 or negative 4 plus 3 is negative 1 or minus 1. Oh yeah, that was not hard at all. So you panicked because it didn't have a point and a slope. It just gave us 2 points, but that was not difficult. All right, let's go with another step of writing the equation, and this time I'm going to tell you something different. So write the equation. And let's say I give you a point. Let's say we have the point 1, 3. Nope, sorry, wrong example. I'm crisscrossing examples here. Say you have the point 6, negative 8. And we know that we are parallel to this line. Y equals 2/3 x plus 13. And we say, oh no, this is definitely not going to meet my needs. This is kind of a little bit sketchy. I have needs. I need a point and I need a slope. Oh, but okay, well, we gave you a point. We have the point. It seems that we're always going to give you the point, so there's no need to panic there. But the slope, all I know to try to find the slope is this thing. How can I get the slope out of that? This is talking about another entire line. It says that our line's parallel to this line. Well, what do we know about parallel lines? Well, if you try to draw 2 parallel lines, they never cross, right? For them to never cross, they have to have the same steepness. Doesn't slope describe steepness? So if two lines never cross, they have to have the same steepness. If they have the same steepness, then they have the same slopes. So parallel lines always have the same slopes. This is just a fact you need to be able to do this. And so what's the slope of this line? 2/3. What's the slope of our line going to be then? 2/3. So knowing that a line is parallel gives us the slope. If I can find the slope of this line, I will have the same slope. So, oh man, that's easy as well. We have this figured out then. So we'll just use our formula to plug in the same batches of information. What's the y value from our point? -8. What's our slope? 2/3. X minus the x value, which is 6. Now this is maybe something you may want a calculator on. Negative makes a +8. Distributing 2/3 times x is easy. That's just 2/3 x. But 2/3 times this minus 6. You may want a calculator, but the 3 and the 6 will reduce down some. And what we'll get is -4. Okay? And then I'm almost finished. I just need to subtract 8 from both sides. And so y will equal 2/3 x minus 12. Oh, that was really nice. Now, this fact about parallel lines is something you need to know. And so we'll write it down just as kind of an extra note. Parallel lines have same slopes. What about perpendicular lines? Such a long word. They have, this is a question we used to ask. We don't ask it anymore, but it's important for you to know. Perpendicular lines have what's called opposite reciprocal slopes. We won't ask you this one on the test or homework or anything, but if I have a slope of 2/5, the opposite reciprocal, the opposite would be, this is positive, so mine would be negative. Reciprocal just means flip the fraction, 5/2. So they have opposite signs and they are flipped fractions of each other. So if they're perpendicular, they have that special relation. We won't ask you that one, but it is something you need to know. All right, so I have one last example where I could ask you to write an equation. For the line. And what's fun about this is, what have we done almost at the end to wrap up every lesson is these special cases. And what are the special cases? Horizontal and vertical. So I could ask you, hey, could you write the equation of the line that is horizontal and has the point or goes through the point 2, 5. So this is great because there's no work to do. You just need to remember, or either try to refresh yourself, which one's horizontal, which one's vertical. Well, horizontal is always going to be y equals some number. Well, what's the y value from this point? 5. Oh, geez, that was easy. Y equals 5. If I wanted to ask you another example, let's say I asked you for the vertical line, and let's use the same point through the point 2, 5. Vertical lines always use x equals a number. Well, what's the x value here? 2. X equals 2. So if I ask you for a horizontal or a vertical line, that's just a special case, which is something you should kind of commit to memory. This is like the last, I don't know, 4 lessons we've had vertical and horizontal lines as special cases. Talking about slope, being able to graph them, now being able to write the equations of them. You need to remember that horizontal is a y and vertical is the x. Okay? All right? Awesome. That's all I have for you. That's actually the end of this chapter 3. So good luck on your test, and I'll see you in chapter 4.